Hello everyone, good morning. I welcome you all for today's session. So in today's session we'll be taking up another problem on thin cylinders. So this is slightly a different one. You can say this is a unique problem. So please concentrate. A 0.9 meter long thin cylindrical shell has 450 inner diameter and 12 thickness. The cylinder is initially filled with water at atmospheric pressure. Determine the pressure at which additional water of 187 into 10 raised to 3 mm cube may be pumped into the cylinder. So there are two cases: ignoring the compressibility of water. Second case, considering the compressibility of water. Take Young's modulus as 200 GPa, Poisson's ratio as 0.3 and bulk modulus as 2.1 into 10 raised to 3 mm cube. Right, so what he is trying to tell here is, so there is a cylindrical shell. He has given the inner diameter, he has given the thickness, right, and it is initially filled with water. And if he is adding some additional water whose volume is 187 into 10 raised to 3 cube, then I need to find out the pressure ignoring the compressibility of water, and in second case considering the compressibility of water. Right, so relatively an easier one, don't get confused. Let me start with the solution part. Right, so as usual, first I'll be calculating the volumetric strain. In order to calculate the volumetric strain, first I need to calculate the circumferential strain and longitudinal strain. So I know that circumferential strain is given by sigma c by E minus sigma L by EME. Right? So further substituting the value of sigma c, I'll be getting PD by 2T. This you keep it as it is, minus value of sigma L is PD by 4T. Keep the E as it is, right? Also you are having 1 by M in this case. So therefore epsilon C is equal to, if I take PD by 2TE as the common term, if I take PD by 2TE as a common term, PD divided by 2TE, if I take this as a common term, what will be remaining here is 1 minus 1 divided by 2 into M, right? So now I'll be substituting the values here. Therefore epsilon C is equal to, value of P is unknown, I'll keep it as it is, and diameter is given to me as 450 so I'll substitute it. Value of 2 is constant because it is a constant term. Thickness is given to me as 12 so you put it as 12 Young's modulus is 2 into 10 raised to 5, and it is 200 GPa, so I'll be taking it as 2 into 10 raised to 5. Put the bracket, 1 minus 1 divided by 2. So this 1 by m, 1 by m value is given to me as 0.3. So that I'll be writing it here as 0.3. So therefore epsilon c will be, so let me calculate. So it is 1 minus zero point 0.3, 0.3 divided by 2, 1 minus answer, so it is 0.85, right? So it is 450 divided by 2 into 12 into 2 into 10 raised to 5 into 0.15. So I'm getting the value as 7.97 into 10 raised to minus 5, right? So it is 450 divided by 2 into 12 into 2 into 10 raised to 5 So this quantity is 9.375 into 10 raised to minus 5. So in this case it is 0.15 into 0.15. Right, so the value what I am getting here is 1.406 into 10 raised to minus 5. Okay, I'm getting the value as 7.97 into 10 raised to minus 5 p. So this is the value what I am getting. Once again I'll confirm it. So it is zero point 0.3 divided by 2 is 0.15. 1 minus 0.15 is 0.85 multiplied by 450 is in the numerator. So this should be divided by 2 into 12 into 2 into 10 raised to 5. So I'm getting the value as 7.96. That I have taken it as 7.97 because third digit is 7.968. Right, so 7.97 into 10 raised to minus 5. Value of p is unknown. I have kept it as it is. Right, now after writing the expression for circumferential strain, I got the value in terms of pressure. Similarly, you need to calculate the longitudinal strain. So longitudinal strain is given by sigma L by E, sigma L by E minus sigma C by M. Right, so once again put the values. In this case it is PD divided by 4TE minus PD divided by 2TE into 1 by M. So once again you take the common term. The common term here I'll be taking it as PD by 4TE. So it is PD divided by 4TE. If I take this as a common term, so it will be 1, and in this case it will be minus 2 by M. Right, so if I are taking this term as common, PD divided by 4T, I'll be remaining with 1 minus 2 by M into the bracket. So once again you put the values of diameter, thickness, Young's modulus and calculate longitudinal strain in terms of pressure. Okay, start substituting the values of diameter and thickness. So P is unknown. Diameter value is 450 mm given to me in the problem. 4 into thickness given to me in the problem is 12 mm. Value of Young's modulus is 2 into 10 raised to 5. So it is 1 minus 2. Value of 1 by m is 0.3. So this if I simplify, I'll be getting the value as 1.875 into 10 raised to minus 5 p. Right? So let me confirm this. So it is zero point 0.3 into 2 is zero point 0.6. So 1 minus answer. So this bracket entity becomes 0.4. So multiply it by 450 and then you divide it by 4 into 12 into 2 into 10 raised to 5. Yes, I'm right. It is 1.875 into 10 raised to minus 5 p. Right, so you got volumetric in order to calculate volumetric strain you need longitudinal strain and circumferential strain. So I calculated both of them. So we know that epsilon volumetric is equal to 2 times epsilon circumferential plus epsilon longitudinal. Right, so therefore epsilon volumetric is equal to 2 into value of epsilon c is 7.97 into 10 raised to minus 5 p plus epsilon L is 1.875 into 10 raised to minus 5 p. Right, so if you just simplify this, I'll be getting the volumetric strain in terms of pressure. So it is plus 7.97 into 10 raised to minus 5 into 2. I'm getting 1.781 15 into 10 raised to minus 4. So I can write it as 17.82 into 10 raised to minus 5. 17.82 into 10 raised to minus 5. 82 into 10 raised to minus 5 P. So you got volumetric strain in terms of pressure. So now I'll be considering the both the cases one by one, and then I'll be calculating the value of pressure P. Right. So first case is neglecting the compressibility of water. Neglecting the compressibility of water. Neglecting the compressibility of water. So in the first case, what is happening? You are already having a cylinder which is filled with atmospheric pressure. Now to that you are adding an additional volume of 187 into 10 raised to 3 mm. So when you are pumping an additional volume at a pressure P, what will happen? Volume is going to increase, right? And that is what I am considering here. So let me put it in the form of words so that you can recall it and you can understand it whenever you go through this problem. So the cylinder is initially filled with the cylinder is initially filled with water at atmospheric pressure. Okay, so this is important. The cylinder is initially filled with water at atmospheric pressure. So this he has given to us in the problem. Now an additional volume of 187 into 10 raised to 3 mm cube is to be pumped at a pressure P. So when you are putting some additional volume of water into the cylinder, what is happening? The volume of the cylinder is going to increase, right? So thus the volume of the cylinder increases and is equal to, so the final volume will be equal to original volume of the cylinder plus volume of water added, right? Suppose if the original volume is 100 mm cube, just an example, right? And if you are adding some additional volume of 187 into 10 raised to 3 mm cube, then what will be the final volume? It will be 100 plus 187 into 10 raised to 3 mm cube. So original volume of the cylinder plus additional volume of water, right? So that will be the final volume of cylinder. So now volumetric strain, just because you are adding this additional volume, the volume of the cylinder is going to change. Just because you are adding this additional volume, initially the volume was pi by 4 d square L. So when you are adding certain water into this, the volume is increasing. So when the volume is increasing, I need to consider volumetric strain, which gives me change in volume. So volumetric strain is given by change in volume divided by original volume, right? So this you can write it as change in volume is equal to volumetric strain into volume. So if you want to calculate the pressure P, you put the value of change in volume. What is the change in volume? Change in volume is nothing but additional water added to the cylinder. So additional water added to the cylinder is 187 into 10 raised to 3 is equal to volume of cylinder is pi by 4 d square L, and epsilon volumetric I have calculated previously in the previous step, so it is 17.82 into 10 raised to minus 5 P, right, into pi by 4, value of D is given to me 450 square, length of the cylinder is 900 mm. It is given as 0.9 meter, so it is taken as 0.9 meter is equal to 900 mm. Because everything is in mm, I also substituted the unit in mm. So this, if you are calculating, there is only one unknown term p. I'll be getting the value of p as, so let me check out what will be the value of p in this case. So it is pi divided by 4 into 450 square into 900 into 17.82 into 10 raised to minus 5. So 187 into 10 raised to 3 answer. So I'll be getting the value as 7.33 Newton per mm square. So I'll be getting the pressure as 7.33 Newton per mm square. So this is neglecting the compressibility of water. So I have not considered the compressibility of water. So this is my answer for first case. Right. So now I will be going for second case, considering the compressibility of water. Okay. The second case is considering the compressibility of water. So in this case, he has given us the modulus of compressibility, or I can call it as bulk modulus. What he is trying to tell here is there is already some water inside the cylinder which is at atmospheric pressure. If you add more water into that, whose volume is 187 into 10 raised to 3 mm cube, if you are adding some additional water into a cylinder which is already filled with water, then what happens? Water gets compressed. Water gets compressed, right? And in order to quantify that, he has given me the modulus of compressibility, or bulk modulus K. So here there is one important catch or takeaway point which we should know. So that is, so let me put it in the form of words. Additional volume of water, additional volume of water to be pumped, to be pumped into the cylinder, into the cylinder is equal to, is equal to the sum of increase in the volume of cylinder and decrease in the volume of water in the cylinder. Okay, so this point is very, very, very important. Unless and until you catch this point or you understand this point, it is very difficult to solve this problem. Okay, so let me underline that point. So additional volume of water is equal to sum of increase in volume of the cylinder and decrease in volume of water. Okay, so what is happening here, whenever you are having a cylinder which is already having water filled inside it, if you are adding some additional volume of water, so क्या हो जाएगा, water will start getting compressed, क्योंकि उसमें already water था, you are adding few more amount of water into that, so water will start getting compressed, right? So water compress हो रहा है. Apart from that, cylinder का कुछ volume था, say it is 100 mm cube, and you are adding some additional volume, तो क्या हो जाएगा, उसका वॉल्यूम इंक्रीज हो जाएगा. सो सिलेंडर वॉल्यूम इंक्रीज हो जाएगा एंड वाटर का वॉल्यूम डिक्रीज हो जाएगा. सो व्हाट विल बी द एडिशनल वॉल्यूम ऑफ वाटर इक्वल टू, सो द एडिशनल वॉल्यूम ऑफ वाटर विल बी इक्वल टू इंक्रीज इन वॉल्यूम ऑफ द सिलेंडर एंड डिक्रीज इन वॉल्यूम ऑफ वाटर. वॉल्यूम ऑफ वाटर डिक्रीज क्यों हो रहा है, बिकॉज वाटर इज गेटिंग कॉम्प्रेस्ड. because I am considering the compressibility of water. Previous case में क्या हो रहा था, I neglected the compressibility, right? यहाँ पे मैं compressibility consider कर रहा हूँ, and that is the reason volume of water is decreasing, and the volume of cylinder is increasing because you are adding some additional volume of water, right? So here the key point is additional volume of water should be equal to sum of increase in volume of cylinder and decrease in volume of water, right? So I know that bulk modulus bulk modulus, which he has given to me in the problem, which is denoted by K, is equal to P divided by right. So it is the ratio of P divided by volumetric strain dV by V. So therefore, if I just rearrange all these things, what I can write here is K into dV by V is equal to P, right? So this is change in volume of water, change in volume of water. So now what I can write here is, so if I just rearrange, change in volume of water is equal to P into V divided by K. P into V divided by K. So therefore, decrease in volume of water, decrease in volume of water is equal to dVW is given by value of P is unknown, value of V is pi by 4 into d square into L divided by value of K given to me in the problem is 2.1 into 10 raised to 3. So therefore decrease in volume of water is 68.1 into 10 raised to 3 P. So unit will be mm cube, right? So if I just confirm it once again, pi divided by 4 into 450 square into 900 divided by 2.1 into 1000, right? So I am correct, it is 68.16 into 10 raised to 3 P. So now, as per the point which I underlined above, additional volume of water, additional volume of water should be equal to volume of cylinder, should be equal to volume of cylinder and volume of water. Sum of increase in volume of cylinder and decrease in volume of water. So the volume of water I have already written it. It has already decreased, so I have not taken a negative sign because I already calculated this. So this point is very important. Unless and until you understand this point, it is very difficult to solve this problem, and that is the reason I told you this problem is very unique. It's very important one, so you practice it thoroughly. Right? So additional volume of water is 187 into 10 raised to 3. So that should be equal to volume of cylinder here is, what is the volume of change in volume of cylinder. So change in volume of cylinder in this particular case is given by, so change in volume is given by epsilon volumetric into volume of cylinder, right? So this I can replace it by this term plus dV of water is 68.1 into 10 raised to 3 P. So calculating further, it is 187 into 10 raised to 3 is equal to volume of cylinder and epsilon volumetric for cylinder. Epsilon volumetric for cylinder I have already calculated, 17.82 into 10 raised to minus 5 p. Right, that I should be multiplying with volume of cylinder, which is pi by 4 into d square into el plus sign, that is this plus sign, 68.1 into 10 raised to 3. Right, so if you just check out this expression, there is only one unknown p, so that p you need to calculate. So if you just simplify everything and calculate the value of p, let me check out what I'll be getting here. It is 17.82 into 10 raised to minus 5 into pi divided by 4 into 450 square into 900 plus 68.1 into 10 raised to 3. So this I should divide 187 into 10 raised to 3 divided by answer. So I am getting the volume in this case as, sorry, pressure in this case as 1.996 Newton per mm square. So the pressure in this case is 1.996, 1.996, that is nearly equal to 2 Newton per mm square. Right, so that is the pressure of water, what you find considering the compressibility of water. Right, so that's it for today's session. Have a great day. Bye bye.